Question 29 starts the series of problems on static equilibrium. Static equilibrium means that our object or a system of objects is in a translational equilibrium, meaning it's not accelerating, it's not moving for that matter, and then we will rely on Newton's first law, saying that our forces will balance each other in all directions, vertical and horizontal. And our other point is that our object is not rotating, meaning that the torques that are clockwise, if there's several of them, equal and balance the torque or torques that are directed counterclockwise. And this is our first example. Here we only have two objects, and they are uniform, meaning that they have centers of gravity right in the middle of them. And the way you can solve this problem is you can think about force of gravity applied here. That would be for the long beam, and force of gravity applied here for the 4-kilogram brick, if you will. So let's see. If we are talking about, and obviously there is a force supporting this whole contraption coming from the fulcrum. So then I can say that force from the fulcrum equals force of gravity on 1 plus force of gravity on 4. That would be our Newton's first law. And second, I'm going to say this is my axis of rotation. That will take out the force from the fulcrum. So then I will say that the torque from gravity 1 equals torque from force of gravity 4. Now the trick here is to figure out the lever arms, because remember, torque equals force times lever arm. I know that the whole thing right here is 2 meters, and then this distance is d. This point is in the middle of 2 meters. Lever arm of 1 is going to be d minus 1, because this is 1 meter and that is the whole d, and that's your lever arm for 1. Then if that is where d is, that is 2 minus d, and then from 2 minus d we're subtracting. If this is middle of 1, this right here is the middle of 1, then I can say that this is 0.5, and it's going to be lever arm for 4 is going to be 2 minus d minus 0.5, which is 1.5 minus d. All right, and then from here I'm gonna go into what is force of gravity is mg times, we decided it is d minus 1 parentheses should be equal to the torque of 4 times g. That's force of gravity on the 4. And then I have my 1.5 minus d. Okay, then we have d minus, then we have g canceled, and here we have our mass is 1, so d minus 1 equals 6 minus 4d. So then this d goes here, this goes over here, and that becomes 5d equals 7. D equals 7 over 5, which is 1.4 meters. And so it looks like 1.4 meters.